All right. So let's do this thing. So these are further identities, nice and vague, right? With the further identities, the first ones that we're going to look at are double angle identities. So if I have these double angle identities, cosine has 3. The cosine 2a can be cosine squared minus sine squared. Could be 2 cosine squared minus 1, or it could be 1 minus 2 sine squared. All right? When you have these identities, pardon me, you're going to use these in this form in trig. That's what this means over here. Use these in trig. You're going to use this form in trig. All right? When you get into Calc 2, this is what you need to have memorized, this derivation. They're going to call them double angle formulas in your book, in your calculus book. I like to call them power reducing formulas because it's taking something that's squared and bringing it down to something that you can actually integrate is the whole purpose of why we're going to do this. But it's just that manipulation. So I'm going to show you down here how you can do this manipulation. So you start off with cosine double angle. I'm going to subtract 1 from both sides. Then I have this negative 2 sine squared. If I divide both sides by a negative 2, that's the same thing as multiplying by a negative 1/2. If you distribute that negative sign, your cosine double angle becomes negative. Your 1 is positive. So I have a 1/2 times 1 minus cosine 2a is equal to sine squared. And that's how I get this. The big deal here is cosine squared you can break down to be this plus, and sine is minus because of the fact that cosine is first here and sine is second. All right, so this is a good one to have on hand because we're going to use it a lot in Calc 2. All right, that is used in Calc 2. Now, that's just cosine. So those are double angle cosines that we're looking at. You can also have double angle sine. So sine 2a is going to be 2 sine a cosine a. It only has one formula. So that's also a good one to memorize because we are going to use both of these in Calc 2. And if I have tangent has a double angle, but that's not one that you're going to have memorized. It's handy for now. That's what we need. All right? Handy for now. Cool. All right? All right. So add these to your reciprocal identities and your what else do we know? Reciprocal quotient identities with those tangent, cotangent, your Pythagorean identities. Here are more to add to that list. Okie doke. The rest of these, you're going to use this in trig right now, but you use them later, but it's just a manipulation of it is the key. All right, tangent, we're going to use it now, and that's it. For example, if I am given the cosine is equal to 3 over 5 and sine has to be less than 0. If I have something that is less than 0, what does that mean? Negative, right? That means negative. So sine is negative, cosine is positive, and I'm going to be charged with finding sine, cosine, and tangent double angles. So in order for us to pull this off, we know that if this is theta, x is a positive 3, and my hypotenuse is always positive. So I've got positive, positive, and this is going to be negative because I have to have the negative 4 because I'm told that sine is negative. And then you literally just plug it into the formulas. That's it. So if I'm looking at this, I know that cosine here is x over r. Sine is y over r. And tangent is y over x, negative 4 over 3. Take these right triangle trigonometry information, and then here I get sine. Okay, so that's 2 sine cosine, so you literally just plug in the sine and the cosine, multiply that out, and you call it good. That's it. So you have formulas. Now with your formulas, go with it. For your double angle cosine, you actually have 3 choices for a formula. It don't matter which one you use. You're all going to come up with the same answer. So use whichever formula you want to use. I don't care. I chose to use this cosine first. Pardon me, sorry. Because cosine was what was given originally. All right. You don't have to. You can use whatever you want. Tangent here, I need to use my tangent formula because tangent is for both of those. Plug that in and work it out. All right. So I'm saying that cosine theta equals 3/5. So here I have cosine theta squared, right? Because this square here means the whole thing is squared. So I'm going to just take this 3/5 and square it. Then you just work it out. 3/5 squared is 9/25 times 2 gives you 18/25. Subtracting, notice I knew I needed a common denominator because 25 was in the denominator. So I keep this common denominator. 1 is the same thing as 25/25. 18 minus 25 is where that -7 comes from, keeping the denominator. It's just algebra, right? Just algebra. Over here, I have -4/3. Don't lose that negative sign. That's our nemesis, right? So keep that negative on there. So I have -8/3 because you multiply across the top and across the bottom. Here I get a square this. Even though it's negative, when you square it, becomes positive. So my minus sign stays there as my minus sign. And then 9 to get a common denominator here, because it's 16/9, right, is 9/9. So 9 minus 16 is a -7. A negative divided by a negative is a positive. Then when you multiply by that reciprocal, reduce your fraction. 3 goes into 9 3 times. And then multiply across. 8 times 3 is 24. 7 times 1 is 7. It's really, it's honestly just that easy. You have to know right triangle trigonometry. Once you know your right triangle trigonometry and you come up with these values, then you just use the formulas. Plug in the values to your formulas, do a little basic math, and you've got it. Cool, right? Nice. Now, this is the fun part because it's those verifying trig identities. They don't go away. 10.2, we didn't do much with them because we just had those sum and difference. We're not going to do a whole lot because I don't care about those as much. But verifying these trig identities, you are going to use some double angle stuff here. But the main deal, I wish I could just, maybe I could do it like this. The main deal whenever I'm looking at these two values is I have to say, what do I know and what do I need to know? As soon as I see this double angle cosine, I know I've got 3 choices. I don't know which choice I'm going to use yet, right? I have no idea. So because I don't know which choice I'm going to use, I'm going to start over here on this side because I only have one identity for sine 2x. Oh, I even say that. Start here because sine 2x only has one formula. See, look at that. It's almost like I know what I'm talking about. So take this because I only have one formula and I don't know which one to use. So cotangent, if I'm going to turn this into sine and cosine, I need to make cotangent in terms of sine and cosine. Here I'm multiplying. This is in the numerator. This is in the denominator. So that basic fraction skills, again, they don't go away either, guys. You got to hang on to those. Anytime you have something that's multiplication, it's fair game. Anything on top and anything on the bottom is fair game. So now I'm looking at this and I'm saying, okay, I have this cosine over sine. No addition or subtraction in here anywhere. So those signs cancel. I've got a cosine left, another cosine left, giving me 2 cosine squareds. Plus 1 cosine 2 theta. Now that I see I have a cosine squared, that tells me which double angle cosine that I'm going to now work with. I'm going to work with the double angle cosine that has a cosine squared in it. Do you see how that works? So you're always looking for the goal. I can't keep saying that enough. You look for the goal. You keep writing this down. My math lab and your book are going to lose one. They're just going to have you work in one side. I don't think that is smart. I don't think it's smart at all. You need to keep both of those sides there so that you keep that goal in mind. So as soon as I see this, oh, check it out. I know now which cosine double angle to use. So I have 1, and here 2 cosine squared minus 1, positive 1 and negative 1 cancel. and then I'm left with the same deal. All right? Look for your goal. What do I have to make this side look like? How can I manipulate these so the sides look the same? You cannot cross over. It's all about simplification. And that's the deal there. All right? Okay, let's do one more. Because I just can't practice these enough. Let me bring this down here so you don't get to see the whole answer up front. Sine squared, secant squared. Sine squared, cosecant squared. Well, that's kind of my best day ever, isn't it? And then secant squared. Well, as soon as you see this sine and cosecant, what do you know about them? Yeah, they are. They're total reciprocal identities. So sine times 1 over sine all day long, baby. That gives me a 1, right? Then I have sine squared over cosine squared is tangent. And why is this amazing? Yep, whammo jablamo. All of a sudden, I just got my Pythagorean identity. So secant squared now equals secant squared. The verifying trig identities is just practice. Knowing your trig identities so you can use them is a big deal. All right? Practice those. Try to memorize them on your own paper. Write them out. And then quiz yourself. You will be better for it. All right?